Hey everybody, Mr. Bucko here with a couple of examples on how to solve a system of equations by graphing for Power Standards Quiz 38. So on the screen here we have a system of equations. We have the equation y equals 2x minus 4 and y equals negative 3x plus 1. There are two equations, and if we have two equations, that is called a system of equations. And our goal is here is to find out what point do these two equations have in common. If we graph these lines, they will intersect at a point, hopefully, and where they intersect is the solution to the system. So when we look at these equations, we're going to start with the top equation. We see that this equation is in slope-intercept form, where negative 4 is the y-intercept and 2 is the slope. So we're going to use that information to draw or graph the line for this equation here, y equals 2x minus 4. Our y-intercept is negative 4, so I'm going to go down to negative 4 and plot a point. Then I'm going to use my slope to find another point that is on the line, and the slope is 2. But if we're working with a graph here, an easy way to interpret slope is as rise over run, or a fraction, and 2 is not a fraction. So we're going to make 2 a fraction by saying that 2 is 2 over 1. So from our y-intercept, we are going to go up 2, we're going to rise 2 and run 1. And when we run 1, we find another point on the graph. We can do it again. From our point here that we just graphed, we can go up 1, 2 over 1 and have another point. Up 2 over 1 and find another point. 4 points is a little unnecessary. We really only need 2, but just to show that we can continue to do that and get this straight line. This line right here is the line for the equation y equals 2x minus 4. Now we are going to graph the equation y equals negative 3x plus 1. Once again, this equation is in slope-intercept form, so we can use that information to graph this line. Our y-intercept is 1 right here, and then our slope is negative 3. And if we're working with a graph here, we would like that to be a fraction, so we're going to pretend that this is negative 3 over 1. Not really pretend, it is negative 3 over 1. That's the same as negative 3. So we're going to go down 3 from our y-intercept, 1, 2, 3, and we go down because it's a negative 3. Down 3, right 1. And when we go down 3, right 1, down 1, 2, 3, and right 1, we find another point. And a point just showed up there. You can't really see that because there's already a point there. Then we're going to go down 3 again from our point, 1, 2, 3, and right 1, and find another point. Once again, 3 points is a little unnecessary. All that we really need is 2, but just to illustrate that these points will all lie on the same line. This line right here is the line for the equation y equals negative 3x plus 1. The solution is where the two lines intersect, the point they have in common, and that point is right here. And the solution is the coordinates for that point, and the coordinates for this point here are 1, negative 2. So the solution to this system is the point 1, negative 2. And if we plugged in this point into each of these equations, we will get a true statement. If we plug in 1 in for x here, our y value will equal negative 2. And if we plug in 1 into this equation, our y value will be negative 2. Have another one here, same type of question, just kind of different equations. Solving the system by graphing. Once again, we have our equation. Our top equation here is in slope-intercept form. Our y-intercept is negative 9, so I'm going to plot negative 9 right there, because that's our y-intercept. Our slope is 9. Notice that's not a fraction, so we're going to say or treat it as 9 over 1. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, because our slope is 9 over 1. Positive 9 over positive 1. So you go up 9, right 1. We can do it again. Up 9, right 1, and find another point. The line that connects these points is the line for the equation y equals 9x minus 9. Now we graph y equals negative 5x plus 5. Once again, it's in slope-intercept form, so we'll use that information to graph the line. Y-intercept is 5. Our slope is negative 5 over 1. So we go down 1, 2, 3, 4, 5 over 1. A point showed up there. You can't really see it because there's already a point there. Down 1, 2, 3, 4, 5 over 1. There's another point right there. Draw the line that goes through those 3 points. And we have our 2 lines drawn for our equations. The solution, where do they intersect? They intersect right there. And the coordinates for that point are 1, 0. So the solution to this system is 1, 0. If we plug in 1 into this equation, we will get 0 out. If we plug 1 into this equation, we will get 0 out. And that is how you solve systems of equations by graphing.